Hello and welcome. My name is Lyndon Smith and I'm the module leader for computer vision and modern control. So going straight into this module, I can tell you this is a 30 credit module. It runs over 2 semesters, but I will be seeing you guys in the first semester because I will do the computer vision bit. Now, this is a master's module. We've been doing it for many years and it runs well. I think the students get quite a lot out of it. Just to give you a little bit of background on where we're coming from, we're looking at computer vision and modern control. And the part I'm doing is using LabVIEW, which is Natural Instruments software. So what is computer vision or machine vision? Well, we're taking images of scenes and we're trying to get relevant information regarding objects or the scene from the images, which sounds fairly simple, certainly simple for humans, but for a computer it's a little more complicated. But this is a typical scenario we might be looking at. So we have a computer interface to the cameras, as you can see, and that I'll talk a bit about how you do that nowadays. With suitable lighting, and that's very important and often overlooked in many books on the subject, to be honest. And then we've got to interface through a GPU, obviously for the user to control the vision system. And we have relevant software. So we're looking for developing some automated solutions to well-defined practical problems. That's what we've been doing in the Centre for Machine Vision, which is in the BRL. We've been doing that for 20 odd years now. Now, what are the benefits of machine vision, you might ask? Well, in industry, people have problems. They're trying to maintain quality of their products, of course, and they're trying to get the efficiency of their operations up. And machine vision is quite a cost-effective way of doing that for various reasons. And we can gather relevant process data and control inventory, for example. And we generally find that this leads to good growth and helps us reduce costs. And of course, the traditional machine learning, the digital machine vision we've been using, computer vision over the years, has now been boosted by the advent of deep learning, which I'll talk about in some detail in the course, specifically convolutional neural networks. Now, if I go straight into an example, actually, to maybe help show what some of the benefits of machine vision can be, I've got here a conference paper which I presented at a conference in San Diego last year. And the idea of it was that we use computer vision to selectively remove weeds from grass. Because you might know that weeds such as dock in grazing pasture are actually a bad news for the animals. They're quite unhealthy for them to eat it. So what farmers do is they spread herbicide all over the place, which of course is bad for the environment as long as it's a bit of a waste of money. And it also kills all the broadleaf plants, like for example clover. So clover is good for the animals, it's also good for the soil, so we want to try and avoid that. So the solution, what's the solution to this? Well, the solution is employ deep learning. And that's me with a paper there waiting for someone to come along I can talk to about it at the San Diego conference. And this is like showing some details from the poster that I had. So this is an example of a typical image you might capture from the grass. You've probably seen this at home in the dockweed. And then, okay, obviously humans can see that's a dockweed, but the computer has to segment it. It has to highlight the region of interest, which in this case is a weed. And then once you've segmented it, it's relatively simple to fire a bit of weed killer at it, or to zap it with a laser, or maybe even use microwaves. But this is not a trivial problem to do automatically, because especially with traditional image processing approaches and feature recognition, because you see, it's difficult for humans when you've got small amounts of dock, maybe 5% of weed. It's not so easy for humans to see it, let alone a computer. But we find that with deep learning we can do this and do it pretty reliably. And there are 2 techniques, which I'll talk about in more detail later in the course, which we developed in this paper. They are transfer learning and data augmentation. And they help you to train your neural network, your CNN, convolutional neural network, even when you've got a relatively small amount of data, which is very important for companies because they haven't necessarily got the manpower or facilities to go collecting huge amounts of data. So looking now at what we've got with this course, the kind of things we're going to talk about are image capture devices like CCD cameras and CMOS digital cameras. Then we'll look at the resolution and quantization. We put quite a lot of emphasis on the importance of lighting, and I talk about image processing, and then data modeling for generating information and knowledge extraction. Techniques for implementing Virtual environments is another important part of the course that I go into. And I'll explain what that means in a bit more detail a little bit later on. Now, if I go to maybe show you a little bit about, maybe talk a little bit about what we've got in terms of Blackboard, what we have here is, we have, of course, in Blackboard, all the information, and you want to keep your eyes on this resource to find out what's going on. I will post announcements, of course, here, and then I will put module information and other areas that are relevant here. Now, module information, I put the module spec in there, which I think is quite worth reading through, and some background information on what the course is about. Now, the important section for me, in the way I've rigged this up this year, is learning materials, actually, because I put in the learning materials section the lecture notes and the tutorials. So you will see it all in there. And if you click on the lecture notes, you will go into there and you will see there's a poster that I was just talking about, and there's a PowerPoint presentation where I put these PowerPoint slides that I'm presenting now for you on there, so you can go through them at your own leisure later on. And I put the paper on there, the San Diego paper as well on there for you. So that's the information on the lecture, but the actual recording of this video you're seeing now, of course, will be available under course materials. So I will leave it there so you'll be able to find it there. Looking at the other areas, of course, I put all the material for the tutorials, not surprisingly, in the tutorial section. So I will put a lot of background information there. Now, the way this will work to start with in the tutorials is what I want to do is spend a couple of weeks getting you into something called Vision Assistant. Vision Assistant is like a high-level shell. It's actually written in LabVIEW. And I should tell you what LabVIEW is. LabVIEW is a programming language, a general-purpose programming language, but it's actually a G language. I'm not sure if you've ever dealt with G languages before, but they're graphics programming languages. So rather than having lines of code, which you have in traditional languages such as C and BASIC, in a G language you have icons, which you place on the screen, which are like subroutines, and then you have wires, which you connect between these subroutines, which data flows along. And that's the way you control the operation procedure of the program, by the means of the data flow along wires. So it takes a little bit to get into that idea for some people, but once you're into it, I think you'll realize it's easier and more intuitive to program in this language than it is in most other languages. And of course, it was rigged up originally for engineers and scientists who didn't want to get into all the idiosyncratic details of how a C program works. They just wanted to get into the data logging in the field or some kind of analysis that they were doing. So all that sort of how the program works in the background stuff is really avoided by means of LabVIEW. So this is a nice gentle introduction to computer vision. We spend a couple of weeks looking at this. Vision Assistant is a nice way to get into it because you can use pull-down menus to see different image processing functions, which then you can see how they affect various images in real time in front of you without having to sort of compile programs and all that kind of thing. And then you'll also see how it will generate LabVIEW code. So what you do with Vision Assistant is you experiment. It's good for example, for calibration and things like that, where you want to just get into using it easily. And you can create scripts in it, which will do a number of processing functions. So you might be get rid of some noise and then do some filtering or something like that. And it will do it automatically. You can keep running the scripts, and that's really kind of a useful way to get into it. Now, and of course, the latest thing you can do with it, which you couldn't do years ago, but nowadays it will automatically generate LabVIEW code for you, and you'll see this when you start using it. Anyway, so that's where I put all the program, all the information for the tutorials. I also put other things on like past papers and case studies you can go through looking at this, and various bits of information. I try to get some guest lectures normally as well. So that's where I put that under learning materials. This Blackboard Collaborate Ultra will be useful for when we actually do the tutorials. Because the tutorials, as you know, are on the Thursday, and the first one will be on the 22nd of October. And we will do it interactively using this. Reading list, I put a reading list on. Try and get you guys into the reading list. I can actually open it up. Let's see. You can actually try and do something with the reading list. It's taken a while. Yeah, so some books I got the library to buy at various times. Digital Image Processing, Gonzalez. Practical book on image processing. Surface inspection, this is an interesting one. It's written by Mel, who's the actual director of the Centre for Machine Vision in the BRL. And he did his PhD on a technique that we're going to talk about quite a bit in the course, which is called photometric stereo. So Mel did his PhD on that, and then he wrote a book talking about it. So it's worth having a quick look at the book to get some background information on this technique. It's a way of recovering 3D data directly from scenes, quite robustly actually. I put that book in the short loan section of the library, so you should be able to get a copy of it there. And there's some control books, because as you know, this course is also about control. So in the first semester, it's computer vision with me. In the second semester, it's control, modern control, with Professor Zhu, Quan Zhu, who was very helpful and will help you a lot on that part of the course. The assessment is 75% exam and 25% for the assignment. And I will issue the assignment in the first semester, and it will be to do with image processing, LabVIEW problem, and also ask you to write an essay in relation to the application. But I'll go through that in detail, of course, later on. So that's how the assessment works. Any questions about any of that, you can always drop me an email, and you've got my email details on the first slide. I think I put that, so not a problem. So that's your background there. If I just go back, maybe back to the, well, let's just see if we can go back to the, just as we're going through this. So different types of materials, different types of information. I put some websites here, for example, and the assignments will be issued here. I'll give you lots of notice about that. I like to get into the course a bit and learn a bit about Vision Assistant and LabVIEW before issuing the assignment. You know, really, I want you to get into it a bit first. So that's it. Going back to where we were on go through the course. So lighting. This is the virtual environment part. Okay. Just going through the basics of what computer vision systems are. We can typically look at things come along conveyor belts is a very classic example. So with the image acquisition device, computing interface equipment, and the software, of course. Well, LabVIEW, Vision Assistant LabVIEW is a software in our case. Now, the lighting, optics, and camera, of course, is very critical, as it says here. You can just read this through. But to be honest, there were very many ways of lighting a scene a few years ago. But the one that's taken over from all of it is LEDs and solid-state devices. And of course, nowadays, lasers are also solid-state devices. And this is the sort of thing we use in the lab. I was just going through yesterday with a student, went through safety training, and he's going to be using a laser to measure some components. And so what we got here is a laser beam. Okay, you send it through a cylindrical lens, and it spreads it out into a plane of light, which is called a line generator. And the line generator is actually quite a complicated, it's quite a precisely made thing because it has to generate an even profile of intensities across this line, which is easier said than done. If you just had a pure circular cylindrical lens in there, it would produce a Gaussian profile, which would be brighter in the middle and dimmer at the edges. Now that would be bad because it would be harder to segment it, as we say, or threshold it and see just the line, because it would be getting dimmer at the edges. It also would produce what we call a hot spot in the middle, which would be extra bright in the middle, which is a bit dangerous from the point of view of the eye. So what we do is we buy special lenses, which are quite expensive actually, but they produce a sort of square wave, if you like, a square wave intensity. So the intensity across that line is pretty consistent, and that makes it more useful to us. So we need some adequate lighting here. We don't want saturation of the sensor, and we can get lasers of different, lasers and LEDs, all sorts of different wavelengths, of course. We're trying to, as it says there, by means of some good lighting, make it easy to distinguish the features and characteristics of interest from the background, really. Talking about LEDs, one thing you can do is get a ring light nowadays. It's a ring of LEDs, and you put the camera looking through the middle, because obviously this has got an advantage if you want to try and avoid highlights, or what we call specular reflections, which are like mirror type reflections from the surface, which sometimes can be a bit of a nuisance. But with this, it's more diffuse light, so you're going to minimize that. And then this is showing a little bit about how the LED works. We've got the semiconductor there and a lens on the top normally. Okay. What do we do with the camera? Well, we're trying to obviously get a decent resolution, high quality image of the scene, and then we're trying to interpret the 3D world by analysing this 2D image, I guess you could say. So these are typical industrial cameras. The difference between these and the kind of thing you buy in Argos or wherever is that these things are usually in metallic cases, and they're kind of calibrated and made robust for withstanding the industrial environment, I guess you could say. But the actual electronics and the way they work is quite similar to domestic digital cameras, really, or even the kind of thing you get in phones nowadays, smartphones. But you might, when you're buying a camera, you often get a lot of emphasis on the number of pixels, the resolution. But to be honest, we don't necessarily in computer vision want extremely high pixel resolutions, because it means if we've got very, very high pixel resolutions that we've got a lot of image processing when it comes to doing anything with the image. We don't necessarily need it. And you'd be surprised at how many decent applications can have perfectly reasonable results by using, say, 5 megapixels. So we have 250 by 2500 by 2000 pixels. We have 5 megapixels, and this will give us enough resolution to do many useful tasks. I mean, for example, we did a project for an Indian company a few years ago, which was to do with non-contact wheel alignment. So we developed a system for them, which was completely non-contact. I mean, normally when you go into a garage and get your wheels aligned, they hang things on the wheels to help with the alignment. But this was no contact at all. And we got it working for them, and it required extreme accuracy, as you can imagine. But we only ended up using 5 megapixel cameras, nor did we need color cameras. They were just monochrome cameras. So the type of lighting, as it says here, it depends on what we need and what we're looking for. Yeah. This is a bit out of date, a little bit texty, because you wouldn't nowadays. Well, it depends. The way it works depends on the kind of camera you've got and the kind of application. We used to have a crazy setup years ago where we had a digital camera, if you can believe this, with an analog to a digital camera with a digital to analog converter, then a TV standard running to a frame grabber in the computer, which then converted the analog signal back to a digital one. And this was a bit crazy. So nowadays everything's digital, really, right from the camera all the way through. You wouldn't want to use a TV standard nowadays. And so the camera optics is also very important, and something else which is often overlooked. It may be that depending on the wavelength of the light that you've got going through the camera, you're trying to see different things. But what we got here is a situation where if you're using light, which is say infrared, you want to make sure you've got a lens which is capable of transmitting infrared light, because they're not all are, of course. Some aren't, and we've had situations where we wondered why we had a poor image, and it turns out it was because we had that problem. This is a lens with a built-in iris that reduces, depending on the light coming into the camera, so this can shut it down in the daytime and open it up at night, so you don't get oversaturation of the image. Computing and interfacing equipment. So we got a PC, of course, and we have to interface it to the camera, as you know. So one way of doing it is, well, these are different ways of doing it. Camera Link is a very high performance system, but we need dedicated frame grabber, which can cost like £1,200, £1,300, £1,400. So if you've got a very demanding application, you might consider Camera Link. Now, FireWire, this is a standard IEEE 1394. There's also the later versions of FireWire, but it's not used that much nowadays. It's kind of been overtaken by USB, and of course it says USB 2, but USB 3 is what we'd be looking at nowadays on this, which is really great because you don't have to mess around with the interface, you don't have to mess around with the system, which is, you don't have the frame grabber, you just simply plug it into USB port, and that's great. GigE is also good, of course, and used a lot. which is also very useful, Ethernet connection. But I would say that USB is probably the way that most of the cameras are going nowadays. The software is critical, I guess. I have to say the software is critical. Now, we could do things like, as it says here, have a switch on the conveyor to measure when things come along and detect them. We can do image processing, and this is what you're going to get into in the tutorials. Feature recognition, that's where deep learning comes in a big way. Image processing, we're trying to improve the image to get the features of interest in the presence of all this background noise, I guess you could say. So that's what we got there, and we're advanced image processing. We're trying to. One thing you could do is combine 2D images to generate 3D data. Now, our technique we've got for that is called photometric stereo, which I'm going to go into some detail. There are other techniques around nowadays as well. You'll find, and people are launching systems and techniques for data analysis all the time, and some of them are quite impressive. You can build up like a cloud array 3D data just from a large number of 2D images of an object. Feature recognition, this is interesting because we're trying to determine features associated with the image that tell us something we want to know about from the image. And I mentioned neural networks there. A convolutional neural network, the deep learning thing I keep talking about, is actually a type of neural network. It's a type of machine learning, in other words. It's a very powerful one. And the great advantage of convolutional neural networks over conventional feature recognition is that traditionally we used to do something called handcrafting. So we decide what features of interest we're looking for, and then we try and find them. But with deep learning, the system automatically determines what the features of interest are. So this is more likely to be performed better because it's just data-driven. It's not us assuming that the feature is going to have a certain shape. So also less work for us, of course, not having to handcraft the features. This will come clearer when I explain it in future lectures. So we're using here LabVIEW, as I say, which is this G language. NI-IDAC, something called IMAC, actually, is the image processing tools that come with LabVIEW. So for all the image processing you want to do, and there's a large amount of it, they spend billions of dollars on developing this software. It will give you lots of functionality. It's a good idea to use as much as you can of the algorithms that they provide, because the functions they provide, functional libraries they provide, because they do optimize the code. It will work quickly. Now, virtual environments, another part of the course I talk about, is there's two aspects of this really. 3D modeling techniques. One thing you can do is you can model things in 3D in a CAD system. Then you can generate orthographic perspectives. You can use ray tracing and Phong modeling and lighting theory, as it says here, and even texture mapping to actually generate photorealistic images. Like this does not exist in reality in this class. It's just been generated in the computer memory. It's a virtual class. Texture mapping is something interesting because normally you put a bit map onto a surface in a CAD system like AutoCAD, and in something called 3D Studio Max, which is their virtual reality software. And then that gives you something looking like a table. What we were talking about here is putting a texture on, a 3D texture on there as well, something called a bump map. This is more of a kind of researchy thing, but a bump map on there. And then the lighting, when you arrange the lighting, the virtual lighting, it will reflect off this bump map in interesting ways and make it look really realistic. So this is the kind of thing if you're an expensive a company doing expensive interior redevelopment, so you might want to do this texture mapping idea. I'll explain more about that later. Now, the other meaning of virtual environments is, of course, got to do with LabVIEW, because they're little subroutines, if you like, or programs that you develop with your G-code. They call them virtual instruments. The reason for that is they used to use them years ago to create like a multimeter, but not a real multimeter, a multimeter that was built into the computer. Because the guys who were using this, they didn't want to have, loads and loads of instruments on shelves. They wanted one computer with all these programs which would allow them to run multimeters or spectral analysis devices, any kind of instruments they want, cathode ray tubes, all virtually, by means of having a suitable input-output card plugged into the computer and then developing it all in LabVIEW, and that's why they called it virtual instruments. And there's a lot you can do with it here, as it says. It's a virtual prototype tool. Something called remote panels is interesting, and LabVIEW was developed for this, with this in mind, so you can control things and monitor over the internet. This is really quite powerful. Just by pull-down menus rather than programming, you could have a product designed in Europe and being manufactured in Asia. You could have it being monitored or being controlled in manufacturing remotely by the guys in Europe who designed it, all over the internet. That's another idea of virtual environment, really. Applications of machine vision and quality control, metrology and reverse engineering. The relationship between concepts of real image formation analysis and the generation of synthetic photorealistic images in VR. That's what I've just been talking about. And of course, I've been talking about the virtual instruments environments and their applications. Now, we're going to get some outcomes. We're going to be looking at the appreciation of the capabilities of machine vision hardware and software, because they're both critical. And in our lab, we do put a lot of emphasis on novel combinations of state-of-the-art hardware, as well as the traditional software with the deep learning and everything else. I think that's the kind of niche we've got. We're looking at, our two niches really are 3D, recovering data directly from 3D by using innovative techniques, and then the deep learning combined with that, which is a very powerful combination. We've used it in loads of sectors, which I will talk about later on. Also, I want to get across the basic algorithms, as it says here, in computer graphics and applied image processing, because I don't want to make out everything is deep learning and just throw deep learning at it and that way. I want to get across the traditional techniques, which are still useful, especially for more structured applications, which will be used a lot. So you don't need complexity. You don't want to make things complicated if you don't have to. If you can do it with traditional image processing, that's probably the way to go. So yeah, especially things like quality control, and the virtual instruments, prototyping, and process simulation. Now, as it says here, we've got the lectures and we've got the tutorial classes, and there's also the web-based material. I'm going to stick as much as I can onto Blackboard and to make it useful for you. Actually, one thing I could put on there is this paper that I did a paper this year actually, but I couldn't go and give it because of the COVID-19. So I actually recorded it. It was for a New York conference. It was held in Amsterdam eventually. And it's got to do with face recognition in 3D. That's what made me think of it, seeing this. So I will try and load that onto Blackboard, because that's a sort of state-of-the-art idea in 3D face recognition. The idea in a nutshell, right, was that if you're trying to detect, because the reason, what we want with 3D machine face recognition is we want to avoid this problem that exists with conventional 2D face recognition, that any system that exists that's 2D can be fooled just by holding a picture of somebody in front of you. So any kind of fancy system by Intel or anybody else can be fooled in that way. So we had a project that this is Gary, was working on in 2007, and we were recovering the face in 3D to increase the reliability and robustness of the face recognition. And this paper I'm talking about, the idea was that you could increase the reliability of the deep learning by looking at the face in different angles. So you recover this face, for example, then you rotate it through various angles, and you carry on training the neural network. Okay, and you wouldn't expect that to improve things, probably, would you? But it did. It improved quite interestingly, quite dramatically. And so this paper is all about that. It's just by changing the pose, effectively, of the person, you can improve the ability to recognize faces in 3D. But I will talk about this system called PhotoFace that we developed and what we did with it. Especially nose analysis was something that the media got a lot of interest in, actually. I went on the BBC talking about it. But it's things like you could use that in things like an ATM. If you were at an ATM, rather than worried about pins, the system could just use your nose as a biometric and then determine it's you, and you'd be able to get the money out. So yeah, we used to be called the NVL, but nowadays we changed our name to the Centre for Machine Vision, and we have a lot of. I will probably do a talk just on the Centre for Machine Vision to give you some more background on that, and it's interesting to look online about what's going on. The indicative sources, these again, the sort of thing I was talking about. This book is an old one, right? But it's worth having a look at. It's in the library. And the reason it's good, I think, is it gives you a lot of basic, well-presented information on traditional image processing techniques. Feature recognition, image processing. And it's a good background to give you a basic knowledge of machine vision. The difference, by the way, between machine vision and computer vision, I would say, our lab is concerned more with machine vision. In other words, we're not thinking purely about the abstract analysis of images. We're also thinking about what use they can be put to in an industrial context and how it integrates into a system. So that's typically what you get with machine vision, whereas computer vision can just be more like an academic study of pure image processing, I guess. The first tutorial that will be held on the 22nd of October is, as I said, it's got to do with IMAC Vision Assistant. Now, all the functionality of LabVIEW is supported in IMAC, even because it's written in LabVIEW, as a matter of fact. So you will open it up, see something like this. You go through, you load an image. Then this is what you'll see in the tutorial. And so you load your image, it appears here, the image. You start pulling down these menus here and processing the image. And then the results of the processing will be available here. Okay. The actual functions you use, the processing functions, are listed here, the ones you could be using. And the interesting thing I was talking about earlier is that the G code, the LabVIEW code, will be automatically generated down here for you. So I think this is quite clever. You just pull down menus at a very high level, it automatically generates a program for you. Of course, there's a limit to how complicated this program can be. You're not really going to be able to implement looping and so on in this way, but it's still pretty good, I think. When I first got into LabVIEW about 20 odd years ago, they didn't do this. You just decided what the script was, what the image processing was, and then you had to write your own program. But they developed it since then, and now it will write a LabVIEW program for you. So I think it's quite nice. So this is a little bit of information here about how to load an image into it, and some tips on how to use it. Preview image I was just talking about a minute ago, that's on that screen. This will all make sense to you when you actually get in and start using Vision Assistant. The best thing to do is to get into it, really, to try using it yourself. Now, scripting is like a macro, really. Scripting is like a macro. So in Vision Assistant, I showed you a minute ago, you put different functions in there, like threshold, say, or filtering or something, and that appears as a function in the script, and you have parameters associated like the threshold value. A threshold is where you set all the pixels above the threshold to white, all the ones below to black, to make it easier for the computer to interpret what you've got, like data reduction. The scripting, it just have a list of functions and parameters, and then that's your script, a bit like a macro. You'll understand this, you'll be able to go through this. You can save the script, and then it could be like on a conveyor belt in a factory. You've got something coming along. You need to do a threshold. You need to find out the outline of it to measure certain dimensions. That would all be part of the script. It would do it every time a bottle comes along. So rather than keep rewriting for different bottles, you just run your script. But this is quite easy to get into. It's quite nice. I've put this little slide at the end here, which I thought was quite interesting, because what this really shows is how machine vision really shows you exactly what's there and tells you exactly what you're seeing. Whereas when humans look at things, the brain can sometimes fool you a bit, and you can get optical illusions like this one. So can you believe it? But in this figure, this region A and this region B are actually of the same intensity or brightness, even though they look completely different to us. You can prove this by getting this image off the presentation and just analysing it in Vision Assistant, and you'll find that the grayscale will be the same here. The brain sees this cylinder and interprets this as a shadow, and thereby makes it look very different. But with software, we can see things exactly as they are. Another example of this is makeup can be applied to the face, and in order to change the apparent shape of the face in a bit of a disguise. But the vision system can see through that and actually remove the effects like that. Especially actually photometric stereo, which I was talking about, and our photo face system, because that can completely remove the pigmentation. So you're just left with a 3D face and the pigment. And you can analyze the 3D and you can analyze the 2D. This enables you to take the reliability of face recognition systems up from what they are at the moment, which is about 95%, up towards 100, near 100. And this could have great benefits because it would increase the number of applications to this technology very dramatically. And thereby you're going to see all sorts of applications. If you want to go on a train, you could just use your face. If you want to pay for things, you could just walk into a shop. Okay, you could have a load of cameras in the shop. They're doing this in California a bit. Amazon are doing this. You have deep learning, look at using the cameras to determine what you're doing. So you're going in, you're picking something off a shelf. The system's working out what you're doing. It sees you going out with it. On the way out, it takes a 3D image of your face to enable you to recharge your credit card. So you don't have to buy, you don't have to carry a card, you don't have to carry a phone, you don't have to mess around with pins or anything like that. So this is a future of convenient shopping, I think, and this kind of thing will really be helpful in the future. It's just a case of people getting into it. I think the technology is almost there in certain ways, actually. So that's my sort of, in a nutshell, description or first introduction to the course. As I say, keep your eye on this, especially on the announcements, because that's where I put in some information there. Any questions, you direct them to me in this part of the course, or when you got into control, you can direct them to Professor Kwan. We'll give you a lot of support. We'll give you lots of industrial examples, and I will talk a lot about the research we've been doing. Because one thing I do say about this course, if I say so myself, is that it's got a great resource. It's got the resource of 20 odd years of all sorts of research for companies all over the world that we've been doing in the Centre for Machine Vision. And of course, it's got the resource also of Dr. Quan's extensive control experience and research experience. So we've got all this resource which we're using to inform the course. So this course is very much not out of a book, which I think would be a bit of a waste of time. But instead of that, we're doing something which is really informed by the latest developments and research and consultancy that we've done a lot of in the last 25 years. So I think you should be able to get a lot out of this course and certainly learn a lot about it. It may be that if you're working for a company, that you might find there's all sorts of applications in your company for this technology where you could save money and increase productivity. And that's happened many times. When students have gone to do PhDs as well, that's happened many, many times. And we've supervised over 20 PhDs already, which have all been successful. So I think we'll have a nice project. As I say, if there's any problems, give me a shout. Otherwise, I'll see you guys next week. Thanks.